A student scored 70 points on a test that had 4 7-point fill-in-the-blank questions and 24 3-point multiple-choice questions. If the student answered one fill-in-the-blank question correctly, how many multiple-choice questions did the student answer correctly? Okay, there's a lot going on here, so we need to be careful that we're organized and methodical in our approach. So, as always, with any word problem that we're using algebra, the first thing we want to do is pick a variable to use, pick a symbol. We'll use x, which is usually the one we use. And what does x represent? And we go to the last sentence in this statement. How many multiple choice questions did the student answer correctly? So that is the unknown that we're looking for. So we'll give it a symbol. Let's say x will represent the number of multiple choice questions. Number of multiple choice questions. All right, and now the rest of the problem is talking about points. The student scored 70 points, had 4 7-point fill-in-the-blank questions, 24 3-point multiple choice questions. So let's think about simplifying the problem in words before we create our equation, before we create our algebraic equation. So what do we know about the points this student is receiving? Well, their points are coming from two different places. There's the points coming from the multiple choice questions, and there's the points coming from the fill-in-the-blank questions. So what we know is that the fill-in-the-blank points plus the multiple choice points if we add them up, we get the total points received. Okay, so this is sort of halfway to our equation. We're still using words, but we're sort of incorporating some symbols. But this should make sense. The total points received are coming from two different types of problems. So there's the points from the fill-in-the-blanks. There's the points from the multiple choices. Okay, so how many points are coming from the fill-in-the-blank problems? Well, the student answered one fill-in-the-blank question correctly. Those fill-in-the-blank questions are 7 points each. 7-point fill-in-the-blank questions. The fact that there were 4 of them on the test doesn't matter. All we care about is how many were correct. So I'm going to cross out that 4 because it's extra information we don't need. There's 4 of these types of problems correct, or 4 of these types of problems on the test. Only one of them was answered correctly. That's the one we care about. They're worth 7 points apiece. So the points coming from those fill-in-the-blank problems, well, there's 7 points. And now, how many points are coming from the multiple choice questions? Well, continuing on in the problem, and 24 3-point multiple choice questions. So again, the fact that there are 24 of them doesn't matter. Right? What matters is that they're worth 3 points apiece. Okay, 3-point multiple choice questions. Okay, so the multiple choice questions are 3 points for every one answered correctly. I'm going to go back and just add the word correct because I want to be more specific. X is the number of correctly answered multiple choice questions. All right, so every one of those is worth 3 points. So the total points received is 3 points per correct answer. So it's 3 times the number of correct answers. And we're calling that X. We're saying there's X correct answers among those multiple choice questions. And so if one of them is worth 3 points, then X of them, the number of points would be 3 times X. And the total points, that's given in the problem. Total points on the entire test is 70. So there's one correct fill in the blank problem. That's worth 7 points. And then there's X correct multiple choice questions, and they're worth 3 points apiece. So we have now the equation 7 plus 3x equals 70. So we've taken a word problem and we've translated it from English into the language of mathematics. And this is the hard part. Like I said before, phase 1 is setting it up and phase 2 is solving the equation. The setup is where all the confusion usually takes place. Once we have this equation, it's relatively easy in terms of this question. This is the easier part of the question. All right, so we need to solve for x. So we need to get rid of the 7 and the 3. We have addition here. The opposite of a plus 7 is a minus 7, so let's subtract 7 from both sides. So these will cancel, leaving us with 3x on the left. And 70 minus 7 is 63. Okay, we're trying to solve for x. Right now we have 3 times x. The opposite of times 3 is divide by 3. So divide both sides by 3. On the left, the times 3, the divide by 3, they cancel, leaving us with x by itself. And on the right-hand side, we have 63 divided by 3 is 21. So the answer to our question, there were 21 correct multiple choice problems.